Okay. Audio is on. All right, cool. Okay. Hey, everybody. Good morning. Welcome to the second lesson of the week. This is going to be lesson 4, comparing quadratic and exponential functions. I have been enjoying the things that I've been reading from you guys, looking over your activities and all of that. So thank you to those of you who have done that. It's been really great. And just as a reminder, of course, if you ever have any questions about what's going on in class or about anything else, you know that I am here to answer those questions either in the live stream or in emails. Thank you to those of you who have already been emailing me your questions. It's helpful for me to get a sense of kind of where everyone is at and what you're thinking about. So keep asking questions, keep checking in with me. It's all helpful. We're all kind of figuring this out together. And I don't think anyone should feel like you're supposed to be able to kind of like figure this all out on your own. It's not, it's too much to do on your own. So reach out to me, reach out to other teachers, reach out to each other if you need help or advice or just looking for someone else to kind of talk about this with. Okay, so jumping into lesson 4, as always, if you don't already have this lesson printed out, or if you aren't already looking at it, do make sure you do that. If you haven't looked at this lesson before, you might be pausing. You should be pausing this video during the video to try these problems out on your own, and then we'll talk about them together. As always, you should have a piece of paper and a pencil out with you doing these problems together, or having the work already completed and going over it along with the video. With that, let's jump right into it. All right, so lesson 4, 4.1. Let me just tab everything open to the right spot. Great. Okay. List these quantities in order from least to greatest without evaluating each expression. Be prepared to explain your reasoning. All right, let's talk about these directions first. So quantities. The quantities are these 4 numbers. 2 to the 10th power, 10 squared, 2 to the 9th, and 9 squared, right? And then we have to put them in order from least, which is smallest, to greatest, which is largest, without evaluating. So in this case, evaluating would mean like plugging them into a calculator, right? Without actually calculating how big each of these numbers get. So you got to figure out a way to rank these from biggest to smallest without actually like doing the multiplication. Be prepared to explain your reasoning. Okay, so go ahead and try this on your own and pause the video, and then when you unpause it, we'll talk about it together. So pause the video, try this on your own. Okay, welcome back. So when we look at these, what I notice when I'm trying to figure out how big these numbers are is that there's like 2 groups that stand out to me. The first group is this number, and this number. Both of these numbers are something to the 2nd power, 10 to the 2nd and 9 to the 2nd. So let's think about those 2 numbers. So if I have 10 to the 2nd power, I know that that is 10 times 10, right? And if I have 9 to the 2nd power, I know that that is 9 times 9. And so if you're in your head, you already are like, oh, well, I know what 9 times 9 is. Great. Or like, I know what 10 times 10 is. Great. But part of this activity is saying, well, I know which one of these is bigger just by looking at them, right? If I do 9 times 9 and I compare it to 10, which is bigger than 9, times 10, well, then I know that 9 squared is going to be smaller than 10 squared, because 2 tens is going to be bigger than 2 nines, right? And I don't need to know the totals to say that. Okay, so let's look at the other pair to see if we can do something similar. So this is 2 to the 9th and 2 to the 10th. So quick recap of exponents. If I have 2 to the 9th power, that means that I'm doing 2 times itself with 9 copies. So 2 times 1, 2, 3, 4, 5, 6, 7. Oh, I need more room. Okay. 8, 9 copies of 2. Right? That's what it means. 2 times 2 times 2, 9 times. And if I have 2 to the 10th power, and maybe you see where I'm going with this, then that's the same thing, right? I'll have 10 copies of 2. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And so which one of these is going to be bigger? Well, I don't need to multiply them all out to know that 2 to the 10th power has more 2's than 2 to the 9th power. So that means I can say that 2 to the 9th power is going to be smaller than 2 to the 10th power. So we can do these kind of two pairs, right? 10 squared versus 9 squared. We figured that out. 2 to the 10th power versus 9 to the 10th power, or 2 to the 10th power versus 2 to the 9th power. We figured that one out. But now what about comparing between pairs? Like, how do I compare something like 2 to the 9th power versus something like 10 squared without plugging everything in? Well, there's more than one way to do this. But when I look at this, something that pops out in my mind is we know that like 2 to the 9th power is 9 copies of 2, right? 1, 2, 3, 4, 5, 6, 7, 8, 9 copies of 2. And I don't really want to multiply all these 9 copies of 2 together, but notice I can do something kind of like halfway. So I know that like 2 times 2 is 4. Yeah, let me give myself some extra room. All right, so 2 times 2 is 4. And these 2's would also become 4, and these 2's would also become 4, and these 2's would also become 4. And then there's like an extra copy of 2 at the end. So I can combine these, instead of saying like 9 copies of 2, I can do 1, 2, 3, 4 copies of 4 with like a remainder copy of 2. And then I'm going to do it again. So multiplying 4 and 4 together is 16. 16. Oops, sorry. Let me spread this out a little bit. So these 2 copies of 4 become 16. And then there's still this kind of like remainder copy of 2. So by kind of condensing it down, we can say like these 9 copies of 2 can combine into 1 copy of 16 and 2 copies of 16, and then like a remainder copy of 2. But now this is 2 copies of 16 plus, or like times, an extra copy of 2. But remember, 10 squared? 10 squared is just 2 copies of 10. So which one's going to be bigger? 2 copies of 10 or 2 copies of 16 with also an extra copy of 2? Well, 16 is bigger than 10, so 16 times 16 is going to be more than 10 times 10, and 16 times 16 times 2 is definitely going to be bigger than 10 times 10. And I can do that without actually finishing this, right? I don't even need to know what 16 times 16 is to say that it's got to be bigger than 10 times 10. So this tells us that 10 squared is smaller than 2 to the 9th. Okay, so using this, can we put everything in order? I think we can. So we know that the smallest number here is 9 squared. So remember, we're doing this from least, which means smallest, to greatest. So the least number is 9 squared because we know that 9 squared is smaller than 10 squared. And we know that 10 squared is smaller than 2 to the 9th. And we know that 2 to the 9th is smaller than 2 to the 10th. So this is the greatest. In a world with internet, you could have also just calculated all these, but the directions said, can you do it without just plugging them all into a calculator? And this is one way. Oops, let me finish this. One way to do that. So that's our warm-up, giving us a brief reminder about how to count exponents, right? 2 to the 10th means 10 copies of 2, etc., etc. And it's also getting us a chance to think about how, like, these squared numbers, even though 9 and 10 are much bigger than 2, 10 squared is still much smaller than like 2 to the 9th power. And this gets us into our lesson goal for the day, which is the goal up top, which says I can explain using graphs, tables, or calculations that exponential functions eventually grow faster than quadratic functions. So just to be really clear, when things are squared, this is when we say that things are, this is when we say that things are quadratic. But when we use higher powers, this is when we say that things are exponential. So we'll explore this more in the next problem, and then that'll be in the next video. I'll see you there.